So I'll be presenting today on the Direct Lake in Microsoft Fabric, a new feature that's introduced in Microsoft Fabric. The tech and the tools now helps to get a better performance in Power BI when accessing the data from one lake. So without much further delay, let's jump into the presentation. So Direct Lake in Microsoft Fabric. Quick introduction about myself. So it's all on the slide. This session, I believe, is recorded and will be shared later on. I'll also try to share this slide deck to be shared somehow, but you'll find this information everywhere. The important thing to note on this one is probably my handles, how to reach out to me for if you have to ask any questions. Everything else is basically what I do, what I've been doing, what I did in the past. That's it. So not much to add there. So coming to the agenda, so we'll be looking at the concept. So what it means, why do you need to know about Direct Lake? A bit of a background on the whole concept of storage in the models in Power BI or analysis services. I will be doing a demo of Direct Lake, how we'll set up Direct Lake, and then I'll go into much more details on the performance impacts with import mode and direct query, which in some way relate to Direct Lake. So coming to the concept, the storage engine behind analysis services or Power BI, your semantic models as such, is actually called as VertiPaq engine. It has gone through many iterations of code names with Microsoft. It's called in-memory database. Sometimes it's called something else in the past. Finally, I think VertiPaq is the name that has stuck around for a while now, and this is the technology that is used behind for storing your data for Power BI when you're working with your data models in your semantic models. In a one sentence, I would say it's the in-memory columnar-based relational data storage. So it saves the data in memory. So it's a faster way of accessing data in terms of physical storage. It follows the relational methodology. So basically your data is stored in tuples like rows and columns, and you should be able to access data in the form of tables as rows and columns. That's where the tabular model fits in. And your column, the data is actually physically saved in column-based storage. So it's a columnar storage, which gives better performance and compression when it comes to storing data and accessing it for reporting purposes and analytical purposes, not as much for the operational purposes. So columnar storage is much more efficient for your reporting analytics workloads. So let's jump into how actually Power BI or your reports or your analysis, any front end that you want to use for analysis, even Excel, connecting to a data model and actually getting the data, how that works. So when you actually try to run a visual or a table or any query, it requires a query to be processed and return the results in the format that can be presented as a visual in your Power BI, right? So I'm talking about Power BI as an example. That's majorly used tool for doing this. So that query is basically an MDX or DAX query. So if we are talking about analysis services altogether, but if you use Power BI, it's mainly DAX. If you're using tabular model behind it, obviously. That query is sent to the formula engine. The formula engine is the brains to work out what's required to come up with an execution plan. And traditionally, if you have worked with SQL Server, you know that there's a CPU part, there's a SQL engine which does the execution plan and then sends that execution plan to fetch the data. So similarly here, there's a formula engine which forms that execution plan, and there are sections of it which requires data, which will be forwarded down to a storage engine. And this storage engine is the one which has the data. And when it comes to import mode, so we are talking about import mode. Let's keep it simple first. So when it's import mode, the data is actually saved in the storage engine. But where does the storage engine get the data from? From your data source. So when you're actually building your data sets in Power BI, You build your data model where you connect to a data source, fetch the data, load the data, and then do your data modeling and save the data. So that data is actually present in your storage engine in the service in the data model. This storage is what we are talking about when I say VertiPaq. So VertiPaq is nothing but this storage engine where the data is stored in memory. So when you open a Power BI file, you see that actually the file loads and there is a certain amount of size associated with that. It's basically that data along with that file is loaded into memory and it's saved in a format which is efficient for your analytical workload. So which is a columnar storage. I'll talk more about how that columnar storage structure is. And this engine is basically the VertiPaq engine. Now, this is basically the import mode. If you are using import mode, this is how your storage engine is structured. What about direct query, right? So there's another way where your formula engine can fetch the data um, by querying the data source directly. And this is direct query where you don't want to save the data in your data model. You just have the semantic model, just the model definition, but the data is fetched at the runtime. Now, if you think about it, there is still certain amount of data that is bought from the data source, whether it's aggregated or the amount of data that is required for your particular visual, not all of it, but only the part that is required. So which is part of your query that needs to be fetched from data source and saved somewhere for it to be presented in the visual. So it's not like somewhere, it's saved in memory. So even though you use direct query, some data is actually cached and to cache that data, it still uses the VertiPaq engine. So it's still efficiently storing that data, even though it's temporarily stored or cached for certain repetitive visuals, it still uses the VertiPaq engine indirectly. So even though it's direct query, there is still certain amount of storage that is required. And for that purposes, it still uses VertiPaq engine. Now, so if you're I've just put together like a few points to understand what a row store and what's a column store that I'm talking about, right? So in row store, your traditional database tables where you save rows. Physically also, traditionally, if you think about your servers in your server rooms, they have physical storages, hard disks or solid state disks. There's blocks of data that's saved and it's saved in a block of contiguous blocks and the data is saved in pages. So because the data is saved in rows, it has to be a whole row saved together as a contiguous block of data piece and they try to put as many rows as possible into a page. So when you try to read the data, the granular level of reading the data is at a page level. So you read a page, you know what rows are in that page. Even though you're only accessing one or two columns, you still have to read the whole page and the whole row to be able to fetch even that one column, right? Whether you're aggregating or not. Analytically, generally, for analytical workloads, you aggregate the columns, but you still have to fetch the whole page, which contains the whole storage of the rows. So your IO will be heavily used, whereas your CPU, once it gets into the memory, the CPU part is to find the row and aggregate and just present you the information. All right. So IO is becomes a bottleneck over CPU. Whereas with column store, your data is actually saved in columns. So each column is its own storage block, whether it's file or a block or a page, or there are different storage units. And this technology existed probably close to 3 decades now, columnar storage. So that concept and different products built differently. Some of them use files, some of them use blocks. So what I'm talking about, a single unit of storage is basically storing the column data, and there are pointers that say which row that column belongs to. For us, it will be hard to navigate, but for CPU, like a machine, it's easy to go and find pointers, right? So because these are machines, so they are efficient finding the pointers and location where the data is. But when it has to retrieve the data, it doesn't have to retrieve the whole row. So say, for example, you have 20 columns in a table, and you are aggregating only the sales amount. You have to fetch only one row. And if you're grouping by state, you have to fetch only one column. And if you have grouping by state, you have to fetch only two columns. So rest of the 6 or 7 columns, we are not even touching them. So the amount of IO reduces significantly. But you can say, okay, you're still retrieving all the rows in that column. There are ways that make that efficient. So we'll talk about it shortly. But to understand, row store is the whole row is read, whereas column store, you're reading only the columns that is required. Okay. So column store optimizes uses CPU over IO, and you all know CPU processing units are evolved much faster compared to the physical storage, the IOs. IOs has always been the bottleneck when it comes to big data and analytical workloads. So I would say like column store, you're fetching the whole column. That means you're probably reading multiple rows in the column, and that is probably required for your workload. But you still want to achieve efficiency when you're reading the whole column, data in the whole column. There are ways to achieve it. So to optimize, there are different ways of encoding and compression, and they are based on certain aspects. So one of the factors that it is dependent on is whether the data is sorted or not. If it is sorted, that means you know that certain amount of data repeated contiguously, and then the value changes, and then it repeats again contiguously. So you know if it is sorted, that means there is some repetition that you can try to compress very easily. The data type, of course, whether it's integer, what is the value range of the data. So based on that, you can decide what type of data it is, and that plays a significant role in compression as well. The other contributing factor is the distribution and uniqueness of data. If you have a lot of distribution, then it's very hard to compress the data because you have so many unique values. But if you have um, better distribution and actually the uniqueness goes down, then you have a lot of repetitions, but that means you can easily compress and get better compression efficiencies. So storage optimizations with encoding, there are many, but I'll just talk about few of them that are consistently used and more efficient, more gives you more results. So value encoding is one of them. To take a quick example here, value encoding. So generally in companies, when you have employees, you have a standard like, okay, the employee number, like your employee number, employee ID will be a 6-digit number, right? There's no particular reason. You just prepare for hiring 990, 999,000 people, over 999,000 people. I don't know when that will happen, but no company is that big. But you decide like, okay, from having that uniqueness, let's have our employee numbers as 6-digit numbers, right? So if you do that, say your first employee is your CEO or whoever it is, it starts with 100,001 would be the first employee. And then you have hired 500 people over time. Some of them left, some of them are still there. You are still able to achieve to only say less than 1,000, okay, less than probably 800. So you have reached like 100,800 employees, right? So if you look at the value range of it, it's basically between 100,001 to 100,800. So you have probably just 800 unique values, right? Some of them are even inactive, but you have only 800 unique values. So what you can do is offset that and say from 1 to 800, right? Instead of considering all the 6 digits, you can save the data as 1 to 800. So your value range is only 800 numbers. And to save values from 1 to 800, so you're offsetting it and saving the values from 1 to 800. And to save a range of 1 to 800, you don't need an integer. Integer is 8 bytes, sorry, 4 bytes. But you can save it into a small int or even a tiny int because it will still give you the range that you require, and you will significantly save like 50 to 75% of your storage cost on integer that value. So I'm this probably employs an example to explain it easily, but there are fields where you have this value range benefits. So value encoding is one way of saving that storage space. So that will reduce your size, and when you read the data, you are reading less size, so your IO will be much quicker. The second form of encoding is hash encoding. So this is more applicable for strings, even for integers, numbers, numerical values, some cases, but mostly applicable to strings, where like you have repetitive strings, like states. In Australia you have 8 states. Sorry, I'm from Australia. I'm taking Australia as a reference. We don't have 52 states like you, so it's easy. So if you have we have our population is close to 25 million. Even if you have 10% of it, Uh, 2.5 million records, only 8 distinct values of state. So there is a huge repetition of that particular field. So what I can do is instead of repeating that state names every time, like New South Wales, New South Wales, New South Wales, I can actually create a pointer and say, okay, I'll say 0 equals New South Wales, and I'll just have 0 as a number. So for 8 values, 8 distinct values, I can fit it into a tiny integer and then have a dictionary to say like a lookup. So all of this will be happening in the backend, but the amount of data that you'll fetch, a varchar 50 compared to, so New South Wales probably is what 10, 15 characters. So 15 characters, you're reducing it to 1 byte. So significant amount of reduction in space, storage space is required. So the IO also reduces significantly. It's only a lookup, so you'll use a little more CPU than usual to be able to do that lookup and get the value. But otherwise, the storage space goes down significantly. The third form is, run length encoding. So this is where you have contiguous repetitive values. So you actually save a range instead of the actual value. So what I mean is, say for your call, if you order your data by state, ideally that's not a good sorting column. So say you have product table and a fact table where you have sales by product. So you have a sorting column by product and state. So for a product that is sold, it can be sold in 8 states, but you have like 20, 200 sales in a month. So there is still a significant amount of repetition that will happen by product. You can group them still and save some storage there. Okay. So there is a point balancing performance versus storage benefits here, because the repetition may not be significant enough to achieve that lookup compensation that you have to do with your CPU performance, right? So I know I'm talking a lot, trying to put a context around this, but let's visually see this and understand how this works. So value I've explained, I believe value is easy to understand, but I'll quickly go through the hash encoding and run length encoding. So I've taken the example of a state, right? So watch R50, that is up to 52 bytes, depending on how many characters you have. So Victoria is an easy one. So there's 8 characters. So it actually saves like 10 bytes required for storing that value. Um, when I have the repetition, like I have 10,000 values of New South Wales, 9,000 of Victoria, 9,000 and whatever that number is, and then 7,000 of Western Australia values repeated. So what I'll do is actually create a dictionary and say 0 is actually New South Wales, 1 is Victoria, 2 is Western Australia, up to 7, so 8 states. By the way, it starts with 0, so 7. Yeah. And hash the values. So now I say, okay, instead of New South Wales, I'll save in the table in the field only 0. And now the storage type that I require to save this value is only one byte, because it's only 8 distinct values. If I can, I want to go even smaller, but tiny int is good enough to save those values. So 8 bits, 1 byte. And I get significant storage space saved here from 52 bytes up to 52 bytes per column. On an average, I would say close to 20 bytes per column to 1 byte per column, per value, sorry, per row in the column. Now, there is still, this gives a significant saving in terms of by using hash encoding. The second is, I know it's repeated continuously. So there is a repetition which is continuous. So what I'll do is a run length encoding and say, okay, state 0 starts from 1, pointer number 1 or row number 1, up to 10,006 rows. So now I've reduced all that 10,006 rows into one row, but just 3 distinct values, right? 3 columns, right? So that way I actually save even further space. So this is pointers, and it looks very easy for the CPU to be able to find the value and fetch it and look up the value and populate it when you require for reporting. But when you're reading the data, it's only one row that is read versus, you know, how much how much amount of data that you have to read. So your IO is reduced significantly, right? So now you have understood the concept of this storage, VertiPaq storage. We will try to understand where direct lake fits. So I've explained how the VertiPaq engine works. Um, direct lake, when it uses VertiPaq for cache data, what is direct lake, right? So let's start from the start. So your DAX or MDX query is required to populate your visuals. So you need some data. You send your query to the formula engine. It prepares the execution plans, understands what data is required. Now it fetches the data from data source. Wait, but this is direct query, right? Now, so what happens here is your data source in Fabric is changed to one lake. And in one lake, it's essentially like a blob storage. So in one lake, the data is saved in lake houses in the format called Parquet files. And Parquet files, the concept behind Parquet files is actually columnar storage. So it is built on the same concepts of VertiPaq engine. It's not in memory, but it still saves the data in the Parquet files in the same format as a column store in in delta tables, right? So I'm not going to go into detail of Parquet files and delta tables. There's so many white papers and articles on that, how that structure works. But essentially what you need to understand is that structure is the same columnar storage structure. The concept is same, the principles are same on which the Parquet formats are built. So now, okay, instead of VertiPaq, why can't I just use that storage because it's still columnar? It's not the same storage, but it's similar storage. So I can work out how to deal with that data without fetching that data into my VertiPaq storage. Now, there is one case where it may have to get it into direct query mode. So this is like a fallback. So when the fallback happens, when the limitations of the Parquet file is hit, like there are some parts in VertiPaq, obviously there are two different products or technologies that is built, storage engines that is built, there will be differences. So your Power BI data model or the model engine is built to work with VertiPaq. So it needs the data in a certain format, in using certain principles. Some of the storage concepts are different. As long as those limits are not hit, it can work directly from one lake. So direct lake works as long as it doesn't hit the limits. But as soon as it hits the limits, then it will fall back to direct query. And this happens seamlessly for you. So when you're building it, you'll see some differences, but not breaking errors when this fallback happens. And when the fallback happens, basically it switches to direct query mode. So it uses cache data, the same concept of direct query. Now, enough of explaining. Let's first see how direct lake works. Like we'll see the demo of how direct lake is built. It's very seamless. You'll not even see what's happening, but I'll show how that works. So for that, let me switch to the demo. Quick word to demo gods, make it work. Um, there we go. So in Fabric, I've got a lakehouse. Again, I'll not go into explaining what lakehouse is. You'd have been in other sessions where these concepts are covered. But if you still have some questions, I'll try to answer at the end in detail. So let's take this one example. So I've got one lakehouse here. What this allows is when I go to this lakehouse, obviously I've loaded my data in there, it's all there. But like a dimension table, a fact table, another dimension table product. So what I'll do is in the top, if you see here, there's something called as new semantic model. So on top of my lakehouse, I'll click on this new semantic model. It fetches the schema and asks to give a name for that. So I'll say direct lake demo ms conf. Um, global. And here I'll select the customer. I'll actually, yeah, I'll select these three tables like this. So what if you see this? So basically, the table is built. You have the table. All this lets you build is the semantic model, and this is just a definition of the model. It's not actually saving the data into the model into the data model. It's only the definition of the model, like the relationships, what the columns are, what the data types are, only that much. any underlying data is not loaded into this model. So this screen looks similar to your model um, model section in your Power BI. So I've got fact internet sales. I'll keep this model simple. So there's a product key somewhere here. I'll make a relationship to product key. So this, again, this visual is me. You can see there's no preview available because it doesn't read any data into it. So I'll just create this relationship between the product key, product table, and the fact table. And it's one-to-many the way I dragged it, not because it knows the data. So this model is created now. So, and it's as you make the changes, it saves. There's no save button or anything. So it's very basically, it's model definition. It's saved automatically. That's all done. So if I go back into my workspace, I can see there's this new semantic model created. And then I can start building report on top of this. All right. So I can auto create a report or start creating report on it. Again, I'll not go into details of how you create the report and everything. It will be covered in other sessions. But you get the idea, right? So I've just created a definition. I'm not fetched the data into it. Now this data is actually in a direct lake mode. So this is not direct query. This is direct lake mode. So the way to check how that is in direct lake mode, I'll launch my Power BI desktop. Uh, Hopefully that's quicker. Everything else stopped. Yeah, cool. I'll open a blank report. I'll go in here and say, okay, get data from Power BI semantic model. And this new model should appear on the top here. So I'll connect to this. As soon as I connect to this, it's just the model definition. So it'll fetch and it'll be a live connect to this model, whereas that model is a direct lake connection to the data which is in the lakehouse. Okay, so you will not see the data tab here. You'll see the model view, but it's the same model view that we have built in Power BI in the fabric. So what I'll do is go in here, sale amount, and then because we didn't build a relationship to customers, so let's just say product category, maybe drop in a subcategory there, uh, there, drop it correctly, yeah. So I get this visual, um, drill down, drill up. Now, when I go in here into view, let's open our performance analyzer. Start recording. I'll just clear this cache again. Now this is refreshed, so I'll probably click on one of them and drill down. And you can see there's a query that's executed. And interestingly, you can see there's a DAX query and there's a visual display. There is no direct query anywhere here. And we know this is not an import as well. So that's one way of telling it's not an import mode and it doesn't have a direct query here. That means it's actually a direct click mode. Now I said there is a fallback sometimes if it hits a limitation. When there is a fallback in the direct data model, you will suddenly start seeing a direct query appear in your performance analyzer. That's when you can say, okay, that query is actually falling back to a direct query mode. Okay, quick time check. I think I'm tracking well, 6:30. I believe this session is 1 hour. Cool. All right. We can go into, looking at the query and everything, but I'll stop this session. Yeah, but you understand how simple and easy and seamless it is for you to build the direct lake data model in Power BI. And you can you don't because it doesn't even fetch the data as the data changes in your lakehouse as you load the data as your data pipelines run your visuals when you refresh it's automatically getting the latest data in your reports. You don't have to import and schedule an import for your data model, right? So that's the beauty of it. And performance wise this is better than direct query, not as good as in import obviously, because import is VertiPaq engine, which is in memory and local to the Power BI data model. The data model sits close to your report. So it's obviously the best performance that you can get is with import mode. No questions about that. You are using direct lake mode only to make sure that you're getting latest data as the data flows into your lakehouse, and you're doing data analysis and those purposes. It's easier to use as the data comes in and you're building some real time kind of reporting. Probably that's where data lake is direct lake is much more you gives you a better performance than direct query. Again, we'll talk about limitations now. So we have seen how direct lake is data model can be created. It's very straightforward. Now we look at when it falls back. Yeah. So the query will fall back to direct query mode if there is any limitations to it, right? One of the limitations is when you when your direct lake model exceeds the skew limits, like the memory or the CPU or any of other resources that is allocated for your SKU, like your fabric SKU, whether you're going with 2 or F2 or F64, depending on which SKU you're going with. If you hit the limits of that capacity, obviously it will fall back to direct query mode. There are guardrails, and this is defined with resource limits. So that guardrails definition is available on Microsoft website. I have put the links on these slides, so you can actually go back and see what those limits are. And when you use unsupported features, I've just put one example here, SQL views. We'll look at what all those unsupported features are. There's quite a few. So when it hits an unsupported feature, then it will fall back to direct query mode. So we'll look at that unsupported feature shortly. But before that, let's see what happens when it falls back to direct query mode. Okay, so obviously the query performance impacted. So your direct query mode, whatever interaction you do in your report, it goes back to the storage engine. It goes back to the data source and reruns the query and fetches the data. It caches to some extent, but whenever you refresh the visuals, you lose that cache, and then you have to actually go back and get the data from data source. So direct query mode is basically, the worst performance that you can get with Power BI visuals is using direct query mode. I would highly recommend not to use direct query mode. If you can use import, go for it. Fallback behavior. What There is a property called direct lake behavior that you can access from your um, the direct lake, sorry, from your semantic model properties. I can quickly show where it is. If you go into your Power BI service, there in the settings, you'll find it over here. I believe it's here. Yeah, I have to find it. I can't remember on top of my head, but yes, it's actually a setting on the semantic model where you can go ahead and change that parameter. So what it says is direct lake behavior. It sets a property. So basically, you have three options, right? Leave it as it is. It will decide when it wants to fall back to the direct query. So your queries never fail. It may be slow, but at least it doesn't fail when it hits the limitations. You can restrict it to direct lake only, so it will never fall back. But the problem is when it hits the limits, it will fail, right? So if you have a tolerance of failure but don't want to use direct query mode, like you have strict restrictions on holding the data in your data model, then probably set this feature. But I wouldn't see why you would set this, because your queries will fail as soon as it hits the limits. There is a direct query only mode, which is recommended for testing purposes to see how your performance is if it falls back, right? So basically, that's the only use case I can think of where you can set this to only direct query only mode when you build the semantic model. I would rather change this model to import mode if you want to have it in direct query only. All right, now I told like there are limitations that if you hit those limitations, it will fall back. This is the full list on the Microsoft website. Obviously, I didn't want to put the bullet points here because this will change this as they fix or as they change the storage formats, or as they fix the storage engine. Probably some of these limitations will go away. At this point in time, as of this morning, this is the list of limitations. Now, issues and limitations, obviously. I'll quickly point to what the limitations are. If you are using SQL view in your lakehouse, or your model is derived from a SQL view, then it can't use direct lake mode. So as soon as you have a SQL view in your data model and your query is using that data set in your data model, it will switch back, it will fall back to direct query mode. Row level security. Yes, pretty much every organization, every enterprise level reporting will have row level security. So that's one thing which will fall back to direct query mode. Composite model. So if you're using um, an import, a combination of import and direct query or dual mode with your direct lake tables, those composite models cannot work with direct lake storage, so it will fall back to direct query. Date time relationships aren't supported in direct lake mode. Only date relationships. So if you are creating relationships using date time columns, avoid doing that. Have a date key, integer, best way to do relationships. If you can't do that, use date columns, not date time columns. Calculated columns and calculated tables, one of the biggest blocker. If you have one of those, then it falls back to direct query mode. High precision decimals and money types. Yep, pretty much one of the important ones that you have for any analytical processing, any financial related analytical processing. You have those decimal numbers and money types. Those ones are not supported. So if you can't use direct lake mode, it'll switch back to direct query mode, fall back to direct query mode. Complex delta table columns types. So like binaries and grids, semantic types. So if you're using those in your data storage layer, in your delta tables, then that will not work with direct lake. Um, okay, there is a workaround for this. Convert these data types into strings. Yes. Um, Floating point value, not a number. That's not supported in direct lake model. Embedded entity. So if you're using Power BI embedded in your organization and you want to work with direct lake model, and if you have that scenario where it relies on embedded entities, then they are not supported. All right, I've put a link to this known issues and limitations, direct link there. This may be like it will update as the product evolves, but at this point in time, there's so many limitations that will stop you from using or falls back from a direct lake model to direct query. So when you design the direct lake model, you build a couple of visuals, everything works fine. You give this data sets to your BI analysts and they start, or data analysts, and they start building reports and they say this is very slow. Probably the reason is it's switching back to direct query mode, and the best thing I would suggest is just change your model to an import mode, which will give them better performance. All right. Cool. Now, how do you actually um, find or measure the performance of your data model? Right. There's this beautiful tool called DAX Studio. If you haven't heard about it or not used it, probably you're not doing the right thing. Start using DAX Studio. This will improve your DAX skills to a different level. Take the DAX skills to a different level. And it also gives you a very good tool set that you can work with to make your DAX much more better. Some of those functions have flown back into the Power BI desktop, but it's still a full-fledged different set of tool that gives you um, more functionality or more tools set. So I'll show you, a little, not too big. I don't have a big data set, but I can show you a difference between import and direct query performance. Direct lake currently doesn't give good picture because it all depends on my internet speed, how much data is transferred, and all of that. So probably not a good use case to show it on. If you have a significantly big model, then probably you will see the difference. Like import is the best, direct lake is in the middle, and direct query is the slowest, right? So, but if I don't have a significantly big model, so to show that. So let's start with this. Right? I'll quickly jump to my Power BI service here. So I've built that model. So I've got the same model copy here. So this is my direct lake model. I need to build a import model. So I've actually prepared a Power BI file just to save time. I don't know how am I running with my time? I lost track whether it's a 45-minute session or a 60-minute session. David, if you're still there, can you just drop a message and say what it is? it is 45 minutes, or how much time I've got?
Yeah, you have plenty of time. You have
Oh, okay.
18
Awesome.
more minutes. Yeah.
Awesome. All right. So it
Yeah,
goes six
up to an
minutes.
hour.
Yeah.
Okay.
All right. So, in that case, what I'll do is actually launch a new hobby desktop. Do it from the scratch. Yeah. So I've got this lake house, right? And the beauty with lake house is I can actually sorry, this one. So I've got my lake house. If you look at sorry, go into my lake house. Uh, there's a SQL endpoint. There's a SQL connection string. Um, Something has changed. I was able to access it somehow, right click and get the SQL connection string. So you can see that actually there is a SQL endpoint for this lakehouse. So this is the connection string. So I'll copy this connection string, go into my Power BI desktop, say I want to get data from, because it's a SQL endpoint, I'll say SQL Server, put in the server name, import mode. Yeah, make sure it's import mode. Click OK. It'll ask for my credentials. So it doesn't ask, it's good. If it asks, let's see. Yeah, it did. Good. Picked up my token. Then you can see like it actually connects and shows me all the lakehouses in my Fabric account. So there is my lakehouse that I wanted to access. And in here, it will show me all the tables. There's a lot of system views that are available, but you can see those dim customer, fact internal sales, and product tables that I've got in the lakehouse. So it's actually connecting to those tables. I will not transform them. I'll just load them. So this is import mode. It's actually fetching the data into my Power BI desktop now. You can see that that will be like the size of that Power BI desktop file significantly increases as it fetches the data. Yep, the memory that file is uses will go up. Where's my Power BI desktop? Right. Yep. Yep. You see that grows as the data is imported into the model. All right. So that data is now loaded. Um, I will create my visual so that I can get that query. So sales amount, product, my category, and then my subcategory under there. So I can test that drill down, drill up functionality very easily. So this is my visual. So I'll open my performance analyzer. So this is a built-in tool inside Power BI Desktop where you can use for um, getting, sorry, analyzing your performance of your DAX queries or visuals. If you have multiple visuals, you will see multiple queries that is run. So this is the query that was run for populating this visual. So you can see the query title, and you can see it's a DAX query because it's import mode. You will not see a direct query. You will understand why I keep mentioning that shortly into the next step of the demo. But you can see the DAX query was prepared. This is basically the formula engine, 8 milliseconds. The visual display happened in 70 seconds, and everything else is 464 seconds. So 464 milliseconds. So I'll quickly refresh the visual again. You can see this actually goes down significantly. But all you need to understand is like this is faster. Yeah. I'll quickly refresh the visual again. You can see that visual has refreshed in just 165 milliseconds. If I go right click and drill down, this is like with the, it's very quick. If I go back, I'll clear, refresh visual. So that's 183 milliseconds again. If I go into my bikes again, drill down, this is done in like 500 milliseconds. So this is pretty quick. It doesn't, because it doesn't have to go and read this data from the database. It's actually loaded in the model. It's import mode. So it's everything is happening in like like 500 milliseconds, 500, 400 to 500 milliseconds. Now, this is import mode, right? The same thing can be measured here. So I'll go into my DAX Studio and connect to the Power BI dataset here. So I've got this untitled one, but I'll connect to the data model that is saved. So import Power BI. I'll start my server timings. So this is the trace that is run. So this starts recording. Now here, when you run the query, this is the drill down query. There is, I can have two queries run at the same time. Okay. Stop this. Two of them run at the same time. Start recording. Go up. I'll just drill down. I want to get the query of this. Do something else. Yeah, there it is. So I'll copy this query. So this is the DAX query that is run. So you'll see that I'll stop this trace, go back into my DAX Studio, connect to my import model. Yep. And here, if I paste it, you can see this is actually the DAX query. So I was doing a drill down. So it's filtering for bikes product category, and it's fetching the filter is applied for the category, and then it's summarizing the columns, calculating the sum of the sales amount, um, and there is an order that's happening, sorting that is happening as well, and then it runs, it shows this data which is used for building that visual. So I'll start the recording, and then the best thing here is I can actually clear the cache, so there's nothing cached. And when I run this query, you can see this runs in about 17 milliseconds. So this is much faster because it doesn't spend any time building the visual. This is the actual time it's spent on running the query. So I can run that again, clear cache, and run that again, and see it actually does about 13 milliseconds. Yeah, 13, 14. So it's less than like 20 milliseconds. That's very fast. Now, the same thing, I'll not go into the detail of actually building the model again. So I'll show you, I've got a direct query model. So here is my direct query model. So you can see it's actually in direct query mode. So I've when I was getting the data from here, I made sure I checked like the direct query mode instead of the import mode. So that's the only difference in building this. So there's nothing else. The query is the same. So I'll stop this performance trace. I'll not be running the trace here. So I'll go to my DAX Studio, change the connection, and connect to my direct query mode, direct query file. So if you connect to this one, so same definition. So the query should run. There's no issues here. I'll clear the cache and I'll run this engine, run this query. Probably I should start recording the trace. Yeah. Starting the trace. I'll clear the cache and then run it again. Now you can see like it's significantly slower. But the time that you notice here, the formula engine is only taking 24 milliseconds, whereas the storage engine is actually going to the data source and getting the data and then presenting it to the visual or the formula. So that's why you can see it's actually 283 milliseconds for actually getting the storage data. So it's not in the memory. It's not in the VertiPaq storage. It's actually in the data source. So it has to go and fetch the data when the query is run. I'll do the same thing, try again, like just to prove the case, like clear cache again. So there's no cache. Now if you run the query, same thing. But if I don't clear the cache, you can see this storage engine one will go down. Oh, didn't. It didn't cache. It's not caching probably. All right. Anyways, that proves the point, right? So it's actually spending more time in getting the data, and storage engine has to do significant amount of work. Um, for direct query mode versus import mode, where it is very well optimized for your query formula engine to directly get the data right away without spending much time going to the data source and getting the data every time a visual is refreshed. I'm talking about a visual refresh, not a data set refresh, like in your Power BI visual. Whenever you click refresh or when you interact, like click on something, filter something, every time it goes to the data source and gets the data, which is very, very slow. All right. Now, so that shows the difference between how you can use performance analyzer to able to capture and prove that direct query is not always good. All right, there would be people who come and argue that okay, direct query, it gives you real-time data and everything. Okay, what is the price you're going to pay when you use direct query? So for every interaction that you're going to do on your report, it has to go to the data source and fetch the data. So it's slow. Um, Obviously, it's a static dashboard. Then there's no point in having direct query mode because you're not getting the latest data benefits anyways, right? So probably if you are having real-time requirements, direct lake is a different option that you can use, which is a bit faster than direct query mode. Okay, so that brings the to the end of this session. So I hope I have provided information. You have learned something from this session that you can take back and use in your um, in your sessions where you can go and explain and learn and use the right mode for your particular use case. So thank you for attending this session. I'll quickly jump to the Q&A panel and see if there are any questions in there. Okay. Oh, there's few of them. So I'll quickly read the first one from Shamin Ayaz. So if I'm pronouncing it correctly. So what app level, workspace level, semantic model level accesses need to be given to users to access data with RLS implemented? Um, Nothing to do with the direct lake, but yeah, there is different access levels that you can provide and control at different levels. So app level, obviously, I believe you're talking about the Power BI app that you publish from the workspace. You have to share the app to the users or AD groups. Workspace level, obviously, there's like viewer and those kind of roles, viewer, contributor, member, and admin roles that you can assign to the users. Semantic model level, um, this is where you can control the permissions to directly share the object, so which is like sharing the semantic model itself for them to use and build the reports. But if you're talking about RLS specifically, that is the security part of the semantic model. So inside, if you build the RLS into your model, then you need to add users to those models, sorry, to those roles in the security section of your semantic model. I can see if I can quickly show something. I don't have RLS built on here, so I'll not be able to demonstrate it, but I can quickly show you where it is. So if you go into your settings of your semantic model, you will see um, security somewhere there. If you have a data set which has roles inbuilt, um, something else from my actual work, but I can show it. Sorry for um, other reasons, various other reasons. But yeah, you'll find like a security part here where you can go and add users to the roles. Um, the next question, hope I've answered that question. Next question from Aziz, how is the data to be refreshed in the data lake when I upload a CSV file into the files section of Lakehouse and then create a table in the table area in the Lakehouse? How you should link the gateway here with the Lakehouse? Um, you don't have to link the gateway because it's not on premises. Yeah, so it's actually all in the Microsoft Fabric workspace. So you don't need a gateway to connect to this dataset. The first part of the question where you upload the CSV file in, so there are different ways of as you upload the files into the Lakehouse, for that to be added to the table, you can write notebooks to append the data from the CSV into your tables. You can directly present that CSV as a table, and because if you're comfortable working with SQL, as the CSV file appears, you can create that as a staging table. So every day you're dropping a CSV file, have a naming format, and then present that as a table, and load the data from that table into other tables. So using SQL. So you can't use SQL endpoint in Lakehouse, but you can use SQL queries in notebooks to do that. So in Lakehouse, the SQL endpoint is read-only, whereas once you move to data warehouse, you can use SQL to modify the data. So as CSV drops, you need to build this as part of your data pipeline, as part of your ingestion and transformation pipelines to be able to read that CSV file as it lands and then loads the data into your Lakehouse tables. Hope I have answered that question. There is examples and documentation around it. So if you navigate to the the data engineering section of the documentation of microfabric, you'll have good tutorials over there that you can do try hands-on with your trial account. Next question, Shamin, what are the limitations with the direct link model? I hope I have covered that in the session. I can quickly show you that link as well. So that link is the best way for you to be able to go and access it. I can, yes, I can actually. So this is the link I was talking about. So known issues and limitations. It's actually in the direct lake overview page itself under direct lake. So this is basically the limitations currently that will fall back or stops you from using direct lake. So I hope that covers it. Um, what stands for I/O? In input output, input output. So physical I/O. So if you're talking about disk, you can't directly do anything inside the disk. So disk is basically where you store the data. But if you have to work on your data, it has to be brought into the memory. Old school explanation, but yes, it's still valid, even though it's in cloud. Um, the way it works is still on machines hosted by someone and run by someone, but it still has to get the data from the physical device into memory and even into the cached data, cache stores inside the CPU to be able to actually work on the data. So IO stands for input output. Yep, that's more one of the biggest bottlenecks and hasn't evolved much. The speed is still an issue with IO. So any optimizations that they can do in the last few decades is on trying to optimize the IO, and that's where the columnar storage is. So I hope I've given you a good understanding of the IO, the compression concept around columnar storage. Yeah, that's 1 minute left, so I'm right on time. Thanks everyone for joining. Thanks for attending. You can always reach out to me on the links that I've shared earlier. Um, ask questions, and if you have any feedback, happy to hear that. Take it and see how I can add more onto this session. But otherwise, thanks for attending. Thanks for your time. Have a good one and enjoy the rest of the conference.